Well, people can get some exercise walking to the microphone. All right, so it's 9:30, which is our scheduled starting time. I see most of the usual suspects. So, welcome to AVTXT. Administrapia, we have Stefan and Ronnie as note takers, and we have Zahid as a Jabber scribe. Join the Jabber room if you feel like it. Blue sheets should be going around. Make sure you sign them. And there's Mitiko if you're interested, either now or later. Note well. Now with a note and a well. Note it well. Oh, good. I got the reaction I wanted from Tim. What? It's a note and a well, obviously. So, yeah, so I assume everybody here is familiar with this. If not, read it, understand it, ingest it. Our agenda today, first we have this agenda bash and status update. Then we'll have the frame marking header extension from Mo. And then a brief item on RTCP feedback for congestion control from Colin, who hopefully will be here by then. But that's mostly going to be discussed in RMCAT this afternoon. And then probably next steps will be saved for the combined end, because unless there's things that are specific to AVTX that people want to discuss. So our working group documents, SDS header extensions was published, so congratulations on everyone there. Splicing notification is in MISRAF on the updated header extensions. I think that's header extensions, right? Did you do it? Yeah. Yeah, header extensions BIS. And RID is in MISRAF on the huge tangle that is bundle and everything related. So I think we can assume that will probably be in MISRAF for a while, but hopefully. CCM layered was marked revised ID needed, but I don't remember why. Do you remember what you were expecting something, an update from?
Stefan here. CCM layer, Ben gave us a very detailed review, which required a lot of changes that were editorial, but quite deep down editorial.
Okay.
We made those changes. I think, Ben, you liked them. However, we missed the upload deadline by 2 hours.
Okay.
So as soon as the upload opens again,
Well, it did. It opens Monday.
Huh? Okay, I will do it now.
Okay, good, excellent. Yeah, and then LRR we believe is ready for working group last call. So since I'm the author of that, Rachel will do that after the meeting. And our other document singular has agenda time. And as usual, document review if you want to your documents reviewed, review other people's documents. This is a prisoner's dilemma here, people. Everybody's better off if everybody helps everyone else. Okay, and if anybody hasn't gotten the blue sheets, they're up here. If somebody comes in, tell them to come up here. And then I believe our first presentation will be Mo. This is the update slides that and by the way, if you downloaded these slides, we uploaded a new version like 5 minutes ago. So
it was only one bullet change, so
yeah.
I can talk to it.
Does this work like this? Does that
I think it's chopping off the bottom.
What?
There's something on the there's a panel on the left.
Let me see what I can do here. Let's switch to single display for this because it's PDF. Let's see if working on it. And where's preview now? Oh, here. Okay, and is that better?
Yep.
Yes.
All right. So this is the RTP header extension for video frame marking, and we're at version 03 of the work group draft. Next slide, please. There is a note well that people should pay attention to. There's been an IPR declaration on this, the 02 version of the draft, and it's most likely related to adding TL0 pick index or adding scalability information in general. I think Jonathan confirmed that's probably what triggered the declaration.
It's TL0 pick index.
Yep. One of the things that we did is to separate the sections that deal with scalability from those that don't deal with scalability. So if anyone wants to expressly avoid the IPR, there's 2 separate sections now and 2 separate extensions that can be used for that. The authors don't really see any major issues with progressing the draft, even using the scalability or non-scalability extensions, because the IPR declaration has reasonable terms in the author's view. So, of course, everybody needs to make their own judgments about that, but take a look. So first, I just want to make sure that the work group doesn't have any objection to going ahead and progressing the draft, given the new IPR declaration.
And since it's my company's IPR, you should probably ask the question. But
Yeah. Okay. So, does the working group see any objections for this IPR declaration?
This is Ben. I'm not here to object. I'm saying you're going to ask that question on the list too, right?
Yeah.
Yeah.
Note taker, remind us to do that.
And I did note in the update that went to the list, I did note that IPR declaration in the update to the list, but I didn't ask for feedback. So good for the chairs too.
Stefan, real quick, this is not news, right? I said that last time when I presented that proposal as well, that there's IPR on that, and that will make it available under friendly terms. So no news here.
All right, next slide, please. So just a quick recap of why we're doing this work, what it's used for. The main motivation for this is to have switched conferencing architectures where the middle box can be, we use the word RTP switch here to generically mean any of the topologies where the RTP middle box is doing switching rather than transcoding on the media. So that could be the media switching mixer or the SFU architectures. And in those architectures, the desire is to avoid decryption and re-encryption where possible, where it's unnecessary, to achieve better scale. And then more importantly, in some architectures like PERC, where the payloads may actually be encrypted end to end, there's no possibility to inspect the payload to look at things like payload headers that have scalability information or have video frame metadata. So this work would be necessary for architectures like that in PERC. And also a longer term goal is to maybe have middle boxes that can do payload agnostic forwarding and still have enough frame metadata to make good decisions about when streams can be resynced, when receivers have proper sync and when they don't. So potentially even supporting a new codec that is not known at the design time of the middle box. Next slide, please. And then a few other motivations are to allow better recovery during packet loss. With some of these frame markers, we can achieve better resilience. The middle box will know better when it has complete information about a frame, when different layers can be decoded properly with all their dependencies met. And the same goes for endpoints. So not just middle box benefits, but also endpoints can take use of this extension to make better decisions about whether or not they can render, whether or not they have all the data they need to render a frame. Next slide, please. Okay, this is the extension as it was in 02 and as it still is in one section of 03. Just a quick recap. There's some bits for start and end of frame, whether or not it's an iframe, whether it's discardable, whether it has a base layer sync point, and then some bits to identify which temporal layer it is, which spatial or quality layer it is, and then most recently in the 02 version we added the TL0 picture index, which is just a running counter, like basically a frame number for the temporal layer 0 base layer frames. Next slide, please. Okay, so the changes in 03 are that we, not just for the IPR declaration, but in general, for efficiency and for simplicity, we forked the extension into 2 variants. So you can basically omit extra bytes at the end of it. And we're able to do that because the 5285 format has a length encoded in the header extension. So if the length that's encoded there is 2, that means 2 extra bytes. So it's actually 3 octets long. That's the original header extension that was defined in 02, the full one with all the fields. But you can simply omit the last 2 bytes. And in that case, the length of the L equals 0 field indicates 1 octet. And then there's only 4 flags: the start and end of frame flags, the independent or iframe flag, and the discardable D flag. And then all the layer IDs and all the fields that relate to scalability are dropped or zeroed out. So that was added in new section 3.1. Comments?
Ronnie Evan. Is it, you say it's for non-scalable stream, but can you also do it in, if you don't want to use the TL0 picked index to signal that this is the interframe or the base layer or something, just in order so you know how to synchronize, at least for synchronization purposes.
Well, so the whole point of this header extension is to provide as rich of metadata as possible to make better decisions. So the more information you omit, the less good of a decision a middle box or endpoint can make. If you choose to omit the TL0 pick index and the layer IDs, even for a scalable stream, there's still use in those SCI and D bits, but then a middle box couldn't easily peel off a layer if it wanted to. It couldn't easily peel off a certain temporal layer or a spatial layer.
No, I understand. What I was saying, it's not only for non-scalable. You could use it also for scalable, but provide partial information. That's what my comment was about. At least to know where you have some synchronization point.
Yeah, maybe we should probably add text there, whether or not you may use this for non-scalable, even for scalable streams, if you're willing to omit.
I mean, speaking as an individual here, I guess. I mean, any stream, if you're in an SRST stream, you can just ignore the scalability and describe just as though it were a scalable stream. That's obviously always possible.
For example, for video switching MCU that wants to ask for a fast update or something, and then he can know just by he just need to know when he can start sending this to the other side.
Right, it's just from the IBIT.
So you don't need all the information; you just need to know.
Yeah, I think that's what Mo is arguing for here.
Yeah, so maybe we'll add some text that just says you may also use the short variant for scalable streams, but the result will be less ability for middle boxes and endpoints to operate on the scalability information. Okay, next slide, please.
Hold on, Magnus is coming to me.
Oh, sorry, Max.
Oh, no, are you coming to the mic or are you just leaving? Okay.
All right, so there's some minor editorial changes. We added references to the various payload specs when we have the sections that map the layer IDs to this extension. So we have references to the 264 SVC and H265 RFCs now. There is one important exception to that. There's a reference that is dangling right now. Bernard's draft on SFU architectures and generic considerations. So we need to decide how we want to dispense with this, either remove the reference entirely or keep it and ask Bernard to try to progress that draft, or we can try to merge the two drafts and see if there's any useful content from that and import it into here. So I'd like to get some guidance. Unfortunately, Bernard's not here.
No, Bernard's in the Metico. Bernard, are you?
Bernard, you got an opinion on this? These options? There we go.
I didn't think they were related.
I think this arose from earlier comments about how do you use, how do you use this, all of these layer IDs and the start and indicators and all that. And I think your draft had some, some text around what a middle box can and can't do and when it can and can't do it.
Okay.
And that's why we added the reference in the first place.
Okay, well, we could just merge that material in.
Okay, so you don't have a plan to progress that anytime soon?
Well, we might, but I wouldn't make it a dependency.
Okay. So let's try to work offline and get whatever blurbs you think are relevant into this doc, and we'll drop the reference.
Conclusion is that, yeah.
We'll remove the reference, but we'll import whatever we think is valid from that document into the spec.
Ronnie, Evan, just going forward, I think the other way to do it is that any document that wants to send that will need, any payload will need to add into the payload how to signal that in frame marking, because you cannot, do you intend in the future to update the document with any new payload that you'll need to describe how to use it with frame making, or to go the other way around, that the payload will say how to use frame marking with this payload?
Yeah, I think that's another point.
Because it's tied to that one. I mean, because if it's this way, then you can say you don't care for it now because it's not active, and then you can later on in the document, if it continues, it will have the information about how to use frame marking with that, and it can say it's also update this RFC.
Yeah, that's the plan for new payload drafts going forward. They should look at this and see how they match with it. But Bernard's draft has more general information about middle box behavior, basically SFU design guide, kind of SFU implementers guide, something like that. So if there's any relevant bits of that we should pull into this spec to motivate why, to explain why would you need these fields and how would an SFU intelligently use them. So we may import a few blurbs from his draft and drop the reference.
So the conclusion, you take some text from this document to the frame marking, and then you'll have some text. You have some text about how to, in the future, to do that.
We'll have to work with Bernard and get the text pulled in.
I'm not talking about this one. About my
other. You're talking about for new RTP payload formats.
New RTP payload format.
No, we don't.
Maybe we should have some directive in the document about it.
Okay, you can put that down in the notes too. That we'll add a.
Yeah, we have sort of similar directives in LRR saying if you want to use it, you should indicate how. So probably similar text there.
We'll add a blurb about that.
Okay.
Okay, next slide, please.
They're going to take Mo's going to work with Bernard to take some text from Bernard's document and merge it into this one.
Not merge the whole document, but some parts of it.
The relevant bits.
And then we'll drop the reference. Okay, so open issues. I think we've already resolved the first one. Nobody has issues with the IPR declaration. We just resolved the second one. We'll work offline with Bernard to import what's needed and drop the reference. Okay, the third one, something Jonathan brought up, is a layer refresh indication, whether or not this header extension can provide that layer refresh indication after an LRR request happens for that particular layer. So I think we probably need to work offline to resolve that. I tried to look at it, and I think there's some changes in text that we could do for the IBIT that could give you spatial layer refresh indication, but it's not clear to me if we have any solution for temporal layer.
Yeah, it's possible we might need additional bits, which would be unfortunate. But
that would be unfortunate.
So the conclusion that we'll keep progressing LRR and we'll make some modification in this draft, right?
Yeah, I don't have a good view right now whether or not LRR would need any mods. So I don't know whether or not you should hold off the work group plus call for it. But my gut feel is that the rules that it states about all the various payload formats, about how you figure out whether or not you got the layer refresh indication, those rules may be, they may be too cumbersome to put into this header extension. So we may have to compromise, and only in maybe high runner cases, you can get the indication easily from the frame marking. In other cases, you can only get it in architecture where you have to dig down into the payload and extract all of the payload headers.
I mean, my feeling is it would be, again, as an individual here, it would be unfortunate for the three group to publish two documents in short succession which are in the same space and don't work together. But if it turns out that if we, after studying it, we don't want to, so be it. But we should at least study it and make sure we, yes, yeah, we should at least study it and make sure, make the decision on purpose.
I think we can get them to agree 75%.
Okay.
But I think there'll be some corner cases where in some payload formats, it's just very, very complicated to infer what happened with layer refreshes.
Yeah, I mean,
it wouldn't be worth it.
Yeah, the other possibility is that there might be rules that if you're doing frame marking and supporting LRR, you have to, you're encoding, you might not get the full flexibility of every possible encoding structure, but you have to sort of make some compromises to support LRR, which is,
Yes.
Yeah.
Yes.
I think Mo and I will figure it out offline.
We'll try to figure out offline today, and yep, and we'll add some text and maybe potentially some new fields in the header extension. Okay, then the final issue was that there was a point raised on the list about adding a frame size. And I think some of the counters to it were to use RID instead. And I think the authors agree with that as a better solution, mainly because RID is probably already going to be available anyway. So there's no need to waste extra octets on encoding a frame size, which would be, I guess, a minimum of 4 bytes of overhead. And RID can also signal more than just frame size. In general, usually the middle box just cares about fidelity, and it could be in multiple dimensions: frame size, frame rate, bit rate, and RID can convey all those different fidelities. And more importantly, it's the fidelities that the application actually said it cares about. So encoding the exact resolution probably isn't that relevant, because the application might not care if it's 1280 by 720 or 1280 by 800. What it cares about is whether it's the class of stream that it wanted, HD or standard def or low res, and RID allows you to define those classes at an application level. So our recommendation is to not add frame size to the header extension and just use RID for that.
Again, speaking as an individual, I'm sorry I'm not going to the other mic, but I'm not feeling well. I would think that if somebody says, no, we really do need frame size in a header extension, it doesn't have to be this header extension. We have any number, you can put any number, a reasonably many number of header extensions on a packet. So
that's right. So if there's no objection, that'll be the close of that issue. So the only one left open is the LR layer refresh, and we'll work offline to get that resolved, maybe even today. Next slide. So that's it. After that one LR thing, I think in those few edits for Bernard's document and for the future payloads, I think we'll be ready for last call.
Any other comments on this document? All right, we're somewhat ahead of schedule, so Colin, you're up next, and anybody who came in who hasn't signed the blue sheets, you want to, yeah. Yeah, do you want to do the blue sheet while you're coming up here? Because I know you came in after we handed them around. You're not supposed to start for another 5 minutes, so sign the blue sheet. Yes.
All right. Hi, my name's Colin Perkins. I love the way they position these pink boxes so that it's impossible to see the slides you're presenting while you're standing in them. I'm Colin Perkins. I'm talking about a draft which is the output of the design a design team in the RMCAT working group, which is trying to do congestion control feedback in RTCP. The authors of the draft are up here. This is the 0.1 version of the draft. The details of this format are likely to change. I just want to give an overview of the current state. Next slide. Okay, so the RMCAT group is developing a bunch of congestion control algorithms for RTP. There are currently 3 candidate algorithms. There's the Google algorithm, which is in, I guess, the Chrome browser. There's a proposal called NADA from Cisco, and there's a proposal called Scream from Ericsson. The goal of this design team, which I'm reporting on, has been to try and build a common RTCP-based feedback to give the feedback you need to run those algorithms. And it's supposed to provide all the information you need such that any of those 3 algorithms can be run with the same feedback formats. The design team did some analysis, decided the working group did some analysis, decided that the information to report was packet arrival times, loss events, and ECN congestion experience marks. The design team has been trying to figure out how to encode those in RTCP. What we have what we are currently proposing is that this information be sent in XR packets as regular feed, along with regular RTCP feedback, or as AVPF transport layer feedback messages. Next slide. So the proposal for the XR packet format, the XR block looks like this. There's a standard XR header at the top, a congestion control report header, which has the XR block type and a timestamp of the report in it. And then you have a bunch of congestion control report blocks, each of which has the SSRC of the source at which it's reporting on, beginning and ending sequence number ranges for the RTP sequence numbers range from that SSRC on which it's reporting. And then for each sequence number, there's a 16-bit chunk, which contains 1 bit to indicate whether that packet was received or not, the echoed ECN bits from the header of that packet, and an arrival time offset relative to the report timestamp in the congestion control header. So it gives you accurate timing, ECN, and loss event marks. The whole thing has to be aligned to 32 bits, so you have to juggle the sequence numbers to make sure that was done, or just include some padding. And the exact format of the timestamps and so on is still being discussed. And you can have any number of those up until the maximum packet size. We also define an AVPF feedback packet, transport layer feedback packet. This has exactly the same information in it as the XR block. The only difference is that in order to match the sort of common AVPF packet structure, which starts with the SSRC of the packet sender and then the SSRC of which is being reported on, we've moved the report timestamp to the end, so it matches the standard format for the transport layer feedback packets. Next slide. So that's basically all I want to say. The draft is going to be discussed in RMCAT this afternoon. There will be a discussion as to whether this is the right information we need for congestion control, which I think is pretty much settled, and perhaps more importantly, how are we encoding it in the packets, and is this the right format? Is this the right bit pattern for the loss and timestamp offsets and all that sort of thing? And also a discussion of what are the overheads of this, and can RTCP using this feedback get the timing we need for the congestion control algorithms? So if you're interested in that discussion, come to RMCAT, and I have a much more detailed presentation about the timing, and also a presentation on the details of the packet format. And there are some proposals for updates to this packet format, which I guess Michael Ramallo will be presenting in RMCAT. For this working group, what we're interested in is whether we're using the XR and AVPF mechanisms correctly, and I guess at least part of that should be for the XR block working group, but I think that isn't meeting, so we're here. And conceptually, is this a reasonable approach? And then we'll figure out the precise details of how we represent the data over the coming months, probably in all 3 of AVTX, XR block, and RMCAT. Thank you.
Jonathan Lennox is individual. I mean, it seems to me a little unfortunate that you have to have two different packet formats simply to humor the the strict wording of some stuff in the the various RTP specs. I mean, my inclination would be to say, I don't think it would change anything architectural in RTCP if we said that this XR block is allowed to be sent in early or immediate feedback.
Yeah, I mean, conceptually, yeah, it's just changing the header, sure.
Yeah.
And whether you send the XR block in early feedback or whether you send the feedback packet as a part of a regular report,
Yeah.
we can figure that sort of thing out.
Right,
Yeah.
and then the other thing
in practice, it's just a different header on the front of the packet,
Yeah,
so it's not a big
and,
deal.
and the layout. But I mean, having to have two different in the header on the front of the packet, I don't care that much. The different layouts of the data in the packet.
Yeah, and we can probably just flip the timestamp
Yeah.
to the end. And
And then the
align.
other thing, sort of, compared to other XR, I mean, many XR blocks have this concept of the thinning, and I'm wondering if that's something that you've looked at. What that does, because I know that there's the concern about how much bandwidth this is taking. So if we could do thinning of the feedback, how much does it do the congestion control algorithm still work, and what does it do?
Yeah, that's an interesting idea, and we haven't discussed it. The approaches we've taken to managing the overhead have so far been reporting less often, and I've got a discussion about the benefits of using the non-compound feedback packets, which buy you a tremendous amount. And my feeling, and I mean, I'm presenting this afternoon, is that we don't have an overhead problem if non-compound packets are used. But yeah,
Randall
has
has
been an
before,
issue.
Ronnie.
Randall Jessup, Mozilla. I got there are two questions. One, as Colin just indicated, there's a question of the bandwidth required in total, and I'm not worried about the high end bandwidth, large bandwidth side, but I am worried about the low bandwidth side, especially if we're trying to use this for audio only calls down to 20 kilobits a second or lower. And there may be some compromises we can use to get to the point where that'll work.
Yeah, I mean, the draft I'm presenting this afternoon in RMCAT, I mean, we can get the feedback down to about 2 kilobits of our TCP, which is a pretty low rate and is within the sort of usual range.
Right. So long as that's sufficiently frequent for the congestion control algorithms to work with, or they can just simply live with it in those situations. The bigger question here I had was, do we really need to have two formats for the same data? Can we just go with the RTCP-FB stuff in non-compound and not do the XR format? Why do we have to do the XR format at all?
So I need to go and double check.
Ronnie Evan, it's because, I mean, if you want to use it with any profile, you need to have the XR, because AVPF is just for AVPF, it's not for AVP.
Yeah, so Colin Pagans, so I need to go double check, but if I recall correctly, it's because the AVPF packets can only be used then under the AVPF profile and in non-compound reports, whereas the XR blocks are needed for the compound reports. And we should certainly, if we can, align the formats. So if we do need to have XR blocks and AVPF packets, then it's the same data in them, and we just change the header. But yes, it looks like currently we do need both formats to satisfy those requirements.
So explain to me how the congestion algorithm is going to work in an AVP non-F feedback setup with the timing rules for AVP, because if the frequency of the feedback we've been talking about is much higher than you can handle under AVP, except maybe at the very low end of bandwidth where we're forced to go down to a lower frequency of thing. Even then, I don't think we can get low enough to do true congestion control with AVP.
It fits within the standard AVP rules. It's in my draft.
Yeah, I mean, I think you'd have to be turning up the RTCP bandwidth.
Yeah. I mean, you have to. I mean, obviously you can't use the 5-second minimum, but RFC 35.
That's what that was the rule. Unless you have a separate thing that says that is we're doing AVP, but we're not really doing AVP.
Okay, but if you let me finish my sentence, the last half of the sentence was that RFC 3550 allows you to disregard that rule.
Okay.
And use the reduced minimum. And as far as I can tell, if you do that, which is allowed by 3550, then and dial up the RTCP bandwidth if needed, then it does fit within the AVP rules. If you use AVPF, that allows you to use the non-compound packets, which greatly reduces the overheads. So I think it's a very good thing in terms of RTCP overhead, but I don't think it's necessary to meet the timing requirements.
Okay. Here's that's
a discussion for this afternoon when I've got a whole long presentation about it.
Sure, and we'll talk more about that. But the question would be, is there any reason not to just say this is only used under AVPF?
I don't think we need to make that restriction. I mean, it clearly works better and has lower overheads if you use AVPF, but I think there are a bunch of cases where it can be used under regular AVP.
Well, it can be, but is there a purpose in doing so?
I don't see any reason to forbid it. If it's the same information being reported, it has slightly higher overhead, and if someone wishes to accept that overhead and use the AVP profile, I see no reason to tell them that they're not allowed to do that.
It's a whole nother section of stuff we have to define, admittedly largely identical. So, okay, well, I just don't see a purpose in it. That's fine.
I mean, I would agree that if you want to use this with low overheads, you should be using the AVPF profile. And I would certainly I would expect this is mostly going to be used by WebRTC implementations which do use the AVPF profile. But since the additional the changes to allow it to be used with AVP are just to say, okay, you can implement this as an XR block instead of an AVPF block, and it's the same. Once we do this right, it should be the same information in that block. Then, but the spec overhead is tiny, and well, if you want to implement it, go ahead, and if not, don't.
Yeah. Well, as long as you don't have to implement it, implement the XR side as well. All right. That's fine. And another method of transferring this data. This might not be an entirely separate thing, which I've mentioned a couple times, is the possibility of piggybacking it in an extension in reverse direction RTP, and in order to avoid having to send separate packets, especially at very low bandwidths. There are pluses and minuses to this approach, but
yeah, I mean, conceptually, that's quite a big change, which I don't know if we necessarily want to do that. Also, it requires the traffic be bidirectional.
Yes.
And that's not always the case.
Yep, and that can be a follow-on or whatever.
Yeah. I mean, it's certainly something that's a possibility, and I mean, there are obvious ways in which you can see how to do that. Yeah, sure.
Yeah. When we get into all the details of very low bandwidth stuff, we'll see if there's a real need for it. If not, it can just be a follow-on or whatever. Okay, thank you.
Thank you.
Okay, Jahed, yeah, kind of like reflecting on Randall's this RTP extension kind of idea. I mean, I think we discussed that on the design team, and we said like exactly for the reasons that you said, Colin. Like we're always assuming bidirectional traffic, and which might not be the case. And I mean, we can take the whole discussion again. I mean, but I don't see, like, at least personally, I don't see like a point of spending time on the RTP extension.
Yeah, I mean, my individual opinion is that we don't need to do it because we can meet all the requirements without. But you know, it's easy to see how we could do it if it's important to do so.
Anything else on this topic? So if you're interested, come to RMCAT this afternoon.
Yes, so if you're interested, come to RMCAT. Well, we will be going into a lot more details in this format. I also have an RMCAT draft IETF RMCAT RTP CC feedback, which I'll be presenting this afternoon. That goes into a lot of detail on the RTCP timing and the overheads of doing congestion control with this. So if you want all the gory details of how fast you can do feedback, either come along this afternoon or read that draft.
Sorry, say that again, Ronnie. No action items. This is not an item for this working group yet. So.
The action item is come to RMCAT.
Yes.
Right.
All right. That's our last agenda item for AVTX. Is there anything else AVTX related specifically, or we'll start switching over to AVT Core, I guess. Going once, going twice. AVT Core. It was empty.
Always empty.
Oh, did anybody else see the second negotiations for X?
Where's the power?
No. Also on the table here.
Oh, let's see. I'll do the slides now. I'll do the slides now.
Yeah, it's just the status. Okay, so welcome to AVT Core. Yeah, okay, so I eat the mic. And now I hear myself properly, I think. So welcome to AVT Core. I'm Magnus Westlund and my coach is Ronny Evan. So we have basically two two working group, 3 agenda items. The 5285 bis this update. Then there's a new independent raised issue about a security issue. And then we have a discussion about merging, which is basically joint with AVTX, which is the merging of the two working groups. The end. So. Control L is to get PDF. Control L. Yeah. Move on. Yeah, the note well, you saw it for the AVTX session. It also applies here, and you have it. So let's move on. No, but we can do without that. It's the note well, which means so. Yeah, as I said, it's the agenda, and let's move on to the status. So we have one RFC published, 7983. On the multiplexing scheme updates for SRTP extension for DTLS. We have 5 documents in the RFC editor. 4 of those are stuck in the misref, and they're part of this humongous bundle called C238, the cluster 238. If you want to check the, it's not only bundle that's in that bundle, so it's there's several things there. So let's see when it comes out, but so, you want to talk to Arya, Ronnie?
Yeah.
Eat the mic.
Hi,
Yeah.
Magnus.
Yeah.
Right, so just a quick comment, Colin Perkins. Just a quick comment on that whole raft of multi-streaming, multiplexing, etc. drafts. I mean, we used to have a multiplexing guideline.
Yes,
draft.
we have another slide on it. So
Okay, you're coming to that.
Yeah.
So on the ARIA, so this one is the one about the not the SDS, but the other 2 registration for MyKey and for DTLS. There are, I mean, they need. There's nothing preventing it from, because we updated the Shepherd write-up, and it's ready to continue.
This is Ben Campbell. I have requested the people that had feedback other than just the intended status to comment about whether this version has made them happy. I have gotten 0 responses from them. So I'm going to poke just a little bit more, but if not, we're probably going to need to do another last call on that one because of the changes. And if we'll give them a chance to reply then.
And there's the one in the area SDS, which is in the working group, and it's ready for working plus call. I send them an email to the authors to see how to do that.
I'm sure I am not an author on ARIA anything. Yeah, it's like really simple. Nobody cares about this. Like, that's why nobody can bother to read it. And like, it's a vanity algorithm, and the IETF needs to determine some process for dealing with it that doesn't waste everybody's time. And like, I am not going to bother to read it. I don't care.
So this is a question. I mean, because this is basically mostly this document are just about registration.
Sure.
And we have to figure out if we allow to register or we don't allow to register. So if we allow to register, we need to register to see how we register those in the IANA registry. Otherwise, I don't know what to do with that.
Sure. So what we've done. So as I recall, these code point spaces are relatively large. At least the DTLS one is what? Is 1 octet or is it 2? 2? Is it really? So what we've adopted in the security groups for these algorithm registrations is we have a table, and then we have a column in the table that says recommended, and it says yes or no. And we allow people to simply register without any kind of review other than the thing exists, and they get marked recommended null. which is what I propose to do here, because like I cannot imagine anybody in this room bothering to read this document and assess it in any way.
Okay, so but I think there was an issue. The issue when it came back in the first place was because for SDS you require a standard track document and not an informational one, which means that it has to go through some to go through to better review than.
Sure.
So we have to figure out.
Yeah.
Sure. So I propose that the people who want this document prepare a revision to every. So look, we have these IANA registries which require proposed standard, right?
So that's why it was divided into two documents. The first one is just the informational one.
Right.
The second one about this one is the SDS, is the one that needs to be standard.
Right. And I'm suggesting that instead these people prepare a revision to the IANA registration section of these documents that makes them not standards track anymore. And once they've done that, then they can register an informational. And if they can't be bothered to do that, then we cannot do anything. Like, I guess my point is, like, as I say, nobody at IETF cares about this. And so if people cannot be bothered, these people need a self-help. And the self-help should be to fix the IANA problem so we can stop thinking about this.
Yeah. So, but I kind of agree with you, Ecker, except that we have had these guys running around for quite a long time. And if we had said them for me that this is what you needed, I would be fine with it. But I think it's, at the current status in the process, it's the wrong thing to say, to give them.
Okay, but I'm still not going to review the document. So
yeah, that's fine. But I think for any future registration, we can give them the task. Okay, we are.
This has been. I'll mark Ecker off the people I'm waiting for reviews from. I kind of agree, and if this keeps, if it's something that comes up over and over, then it doesn't have to be the proponents of this document who proposed changing to the IANA policies. So let me talk to the RDDs and other RDDs, and we'll figure out how to deal with that. Yeah. As far as the informational one, I think I doubt it's going to be an issue running that one through.
And that's the first one, the one that's within your review.
Right. The one that's in the
ISG
right now.
Yeah, that's the first one.
Yeah, I mean, currently we have no other additional document which want to register and or proposes new crypto algorithms for SRTP. So it's. Yeah. So there's no presentation or any talk around the multipath RTP. It needs reviews. Let's see if we can actually get forward with this. So please review it.
Okay, I think I have one who probably will. I have someone to review that.
Okay.
Someone asked me about this, so
yeah, speak up in the mic if you want to speak.
Yeah, okay. We'll solicit for reviewers for that document because we want to progress it. I said we will solicit for reviewers for this document in order to be done with that, because we think we should be finished. That's one of the last milestones that we still have on our AVT core. Next slide.
Yeah. So now, Colin, we get to the guidelines. Guidelines for using multiplexing features of RTP. So I'm your co-author. Colin is a co-author. I think it's Harald too. It's basically we let this. I had a task to actually do first attempt to do a new revision, which significantly changed this. I think it's still a useful document. There's been enough discussion around it. We have this in various working groups. I think we actually need this guidance document and let people, that we can point people to so they can read and try to better understand in some cases what the different multiplexing points are for, and etc. and intended for. So, did you have anything to add, Colin?
Hi, Colin Perkins. No, I don't think I have anything significant to add. I was mostly getting up to ask whether you still. Sorry, you have to get far too close to these microphones. Colin Perkins, I don't have anything significant to add. I was mostly coming to the mic just to check if there were plans to continue with this or whether you regarded it as obsolete. I guess I'm happy to still contribute if you think that's useful. It's not clear to me quite what we're going to put in it, but obviously, if you have a proposal, I'm happy to contribute if that's helpful.
Yeah.
So it's your action item.
Yes.
Okay.
Yes, we have a milestone. Next slide. Yeah.
And here's the milestone. So we have the RC 5285 bis. We have slides on that after this presentation, and the guidelines. That's the question that you asked, Jonathan. And we have the MP-RPT also. We'll probably need to update for the last two. We need to update the time for them for the milestone, and I think the 5285 was almost done, so there's no reason to update that milestone. So this is the last slide.
Yeah.
Okay.
Yeah. So, any other questions around the status of the working group? We move on to the update of 5285, the general header extensions. So. Yeah. Yeah.
Okay, so the update to 5285. Next slide. The changes from the last IETF meeting, we addressed comments from Colin and Magnus. It's mostly editorial. We put some emphasis on what can be sent as an RTP header extension. And this is an important note there. The header extension can be ignored or discarded without breaking the RTP layer. For example, mid, as specified in bundle, RTP header extension might, if removed, disrupt the behavior of the higher level application that build on RTP, but is acceptable since it doesn't affect the interoperability of the RTP stack itself. So this is the major emphasis about what can be done inside an RTP header extension.
I'd ask this is gibberish. I mean, you can't remove this mid and expect things to keep working, right? It doesn't work. You could, it's like, it's a UDP packet still, so it's fine. You could do anything. Like, what is the purpose of this text? If it's to say you can't remove header extensions, then this text doesn't work.
No, that's not what it means. Okay, Colin.
Hi, Colin Perkins. I think it would have helped if you had given a little more context, Ronnie. Okay. The previous versions of this draft and the RTP spec say RTP header extensions must be ignorable. And if they're stripped off, then the application must work. What this is intending to say is that it is acceptable to have header extensions. So it's if say header extensions must not affect the processing of the RTP layer itself if they're stripped off, but it's acceptable to define header extensions which, if stripped, will potentially break higher level things on top. So, for example, the mid previously, I think, would not have been an acceptable header extension because if you strip it off, it breaks stuff. But obviously, there is the possibility that there are middle boxes which do strip that header extension off. So what we're trying to say here is that since it doesn't break RTP processing, that's an acceptable thing to put in the header extension, and the higher level applications will just have to be able to cope with the fact that there might be middle boxes that strip that out. And if this wording isn't the right way of saying that, we should sit down and figure out a better way of phrasing it.
Ronnie, I think it's the text is there in the document because the text says about telling Middlebox not. We added also text recommending Middlebox not to remove RTP header extension, where before it was accepted that they can remove it, and we don't have any control about it. And the other text we added is more information about how to have a better probability that it will come end to end, because of UDP packet dropping in the middle. So how often to send that, and in order to have a better probability that it will go through.
So I get what you're trying to do. I don't care deeply because I think people are going to ignore all this. But when you publish stuff like this that is clearly not true, it just causes people to ignore all the other stuff that's in the document too. I get what Colin's saying, that it doesn't break the RTP processing, but unquestionably breaks a large part of what I think is the RTP stack, and the packet is unquestionably not going to work. The advice to middle boxes should be, if you remove the headers, you have broken the system, right? Which would be equally true, definitely true for doing authentication, right?
So there's text about it. There's text about it in the document. Okay, so.
Right. Colin Perkins, so we cannot make that advice because that's not possible for certain types of middle boxes, such as mixers, which have to remove the header extensions. So, since they're generating a new stream. Now, they can potentially regenerate a new stream that has an equivalent header extension, but they have to strip the header extension.
But they have to be part of the signaling process of negotiating the header extensions to make sure that it works in that system in a compatible way, or it will fail, right?
And that's
Absolutely, but that's for the higher level system to define and not for the RTP specs to define. Okay. So, for example, the WebRTC specifications could say, you can't strip these header extensions because it breaks stuff if you do, and that would be a perfectly sensible thing for the WebRTC specs to say. At the RTP level, there are use cases which have to strip those extensions, so we can't make that a blanket requirement here. Because some of the middle boxes we have defined in the architecture, the way they work cannot not strip them.
And this is more like guidelines for review of the documents. This is more.
Yeah, Jonathan, I think the other thing this is trying to say, and again, the wording may not be right, is you can't have a header extension that says like, okay, now sequence numbers are little endian instead of big endian, or now this changes what, how you decode this packet. So basically, things that are, you can't be changing the fundamental behavior of RTP with a header extension.
Yeah. Okay.
If you need to do something on that scale, that's a new RTP profile.
Next slide. Okay, so the next step for this document, we addressed all comment from the list, and I think we are ready for working with plus call and publish. We had reviews both from Colin and from Magnus, so it looks like we got some decent reviews on this updated document, and of course the other authors like Dave Zinger also said followed this discussion and gave his feedback on those comments. Okay, that's the last slide.
Yep. So
we will do a working plus call.
Yes, but we'll go to working plus call soon. So, and when I mean soon, it's probably later today. I think we're there. So. Okay, Martin.
Kind of grateful that I didn't get time in SAG to talk about these, because otherwise I'd been in two places at once. Let's go on. So I don't know, we haven't had a lot of discussion on this draft, and I've had a number of discussions with people privately, and they've all expressed concerns that they don't actually understand what's going on. So I thought maybe it'd be worth going through what the attack is here. I will project, sorry. No, I'm going to stand here like this. I'm lazy. Unknown key share attacks are attacks where there is some confusion about the identity of a peer in a secure in a potentially authenticated context. You think you've authenticated someone, and it's actually someone else. The Sigma paper, which is one of the papers that actually goes to great lengths to define these and deal with them in protocols, actually calls this an identity misbinding attack. It's where you actually have the identity of your peer is bound to the keys in an incorrect fashion. Next. So this is a sort of example of one potential formulation in a sort of abstract protocol that we might have. You might recognize some of this from DTLS SDP. We have a client that talks to an attacker. They ask for the attacker's key. The attacker gives them a key. That key is actually owned by someone else. The private key associated with the public key is actually owned by someone else. And what happens is that the client talks to the attacker, and the attacker simply forwards the connection to the person who really owns the key, and the connection is established end-to-end between two unsuspecting parties. In this case, the patsy is unaware of the fact that anything's wrong, and in fact, from their perspective, everything looks right. They're authenticating the client, Norma, quite happily, but Norma thinks they're talking to Mallory, and we have an asymmetry in the beliefs of the parties involved in the situation. This is sort of different to the case where you have media copying attacks, if an attacker was copying the media, terminating the TLS connection and simply copying the media into another connection, it would be obvious to both parties that they're talking to the attacker. So Norma and Patsy could be talking to the attacker, and that's not a problem. There's some nuance in this that I haven't got in my slide deck because that's even harder to explain. I'll just get to the attack itself and we can discuss the implications. Next, please. So this is the Dane example in text, very similar to the one above. The attacker advertises a TLSA record with the raw public key in it, again, against their domain name. That raw public key is actually someone else's. Someone else has the private key for that public key. Someone tries to connect to the attacker. The attacker forwards all of that traffic on to the patsy, and the client validates the connection using that key, ignores all of the certificate checks according to this RFC that was published, and they think they're talking to the attacker, but they're actually talking to someone else entirely. And this is a kind of a big deal for the web origin model, because you can do all sorts of things with cookie exfiltration and various state that you hold in browsers and things like that. But that's not what we're here to talk about. We're here to talk about the boring attack next. So this is the model that we're familiar with. This is the sort of model that we're assuming in the draft. You have some signaling path over which the communicating peers exchange fingerprints. Now we assume that this path has integrity, and that means that the signaling process actually ensures that the peers that are involved in that process are the ones that it expects. There's no way for someone to subvert the signaling process other than what they advertise themselves. Presumably, both of these people are using some form of authentication with the signaling service. They have a password or login or something like that that allows the signaling service to be sure that whatever identities it's binding to that session are correct in its terms. And then we have a media path that is using DTLS or TLS, and on that path, both parties advertise the certificate they're using and prove that they own that certificate. Both parties check that the fingerprint that they saw over the signaling is the same as the one that they got from the certificate of the counterparty. Everyone should be familiar with this. This is very old. Next. So the attack that we have relies on the fact that we have two concurrent sessions from the same honest endpoint at the same time, and they're using the same key. I think a lot of implementations reuse their certificates for multiple connections. Very few of them will be establishing multiple connections at the same time, unless you're in certain across multiple sort of SIP layer sessions or application layer sessions. There might be multiple TLS connections within the same SDP, but it's rare that you're actually getting different identities associated with those things. The draft actually talks about how you can use the same attack to switch connections around within the same session, but I didn't find that to be particularly interesting, since that's something that an attacker could do anyway, regardless of what promises we provide here. And so the attack allows, this attack basically enables an attacker to switch one session with one person. So I want to talk to Colin and I want to talk to Ben. If Colin was a bad guy, he could convince me that I'm talking to him, but I'm actually talking to Ben. Next slide shows a picture. Yeah. Bad guy, someone else that you're willing to talk to. And you can basically redirect the communication from the bad guy to someone else. Now, the observation here is that this connection won't complete unless the patsy is willing to actually talk to the person who's making the call in the first place. And this is what limits the attack to the switch that we see, and not something far more general. And it also suggests one possible solution to the problem, which is every time you make a connection, if you had a different fingerprint, you would not be vulnerable to this attack because you would look like someone else entirely. And they would see your certificate coming in and say, that's not expected, go away. That is kind of saving grace, I guess, with WebRTC, because we're actually generating new certificates on every connection there by default. However, we do have APIs to allow someone to reuse that. The other thing that the attacker needs to do, which is probably more challenging, is convince this victim that this particular session has been broken in some way, and that probably means access to the media path in some way. So not only have we stepped up the requirements, we've stepped them up to on-path attack. Next slide. So the conditions. So a victim needs 2 concurrent sessions. They need to use the same key. They need to be willing to talk to 2 different people, including the attacker. The attacker copies the fingerprint from one session into the other. It needs to know about the victim. It needs to know that they have multiple sessions. It needs to know the fingerprint attributes from the patsy. It needs to forward the DTLS packets. Okay, that's fine. That means it needs to know the transport parameters for the person that it's going to forward them to. And this is all possible because we assume that we have integrity but not confidentiality for signaling. And quite likely they need to block somehow the session that's going on between the second session that it wants to sort of hijack. So, next slide.
So the attacker, just a question, the attacker needs to know that there are 2 sessions in order for it to succeed.
Right. It needs to know one that it could use. Yes.
It needs to know that the victim has 2 sessions.
And they need to be in a state where it's possible to exploit them as well. So they need to be basically established at the same time.
It's very...
Right. That's why the next slide.
Okay.
So, yeah. I actually want to challenge the need for 2 concurrent sessions.
Ah, yes. We went through this at great length and concluded this was the only way to do it.
So this is a little hard to reason about at the microphone, but here's the situation. You absolutely can set up a situation in which you have only 1 session. But because the reason unknown key shares work in, say, Dane is because the identities are actually in the certificate. And so you bind, when you make a, when the client connects to the server, but is confused about the server's identity, the client's identity, however, is carried in the certificate. And so the server ends up believing he's talking to the client, but the client thinks he's talking to the attacker. If you only have 1 connection, what happens is that the client and the server both believe they're talking to the attacker when they're talking to each other. And the attacker can always create that situation just by having just by terminating 1 call and initiating another call. And so it's unless you have some sort of cryptographic binding sitting above the protocol, basically it's a strictly weaker situation because in the existing unknown key share, basically the attacker can't read the data, whereas in the back-to-back thing he can read the data.
Yeah, but yes. So I mean, if you have a situation where you you basically have two signaling system and impersonate the other side, so to say, in each system. Then you can actually have, looks like you're talking, convince the server side that you're talking to, that you are, let's see, Norma, and use that, say, okay, I'm going to claim I'm Norma to Patsy, get the signaling, get the key from Patsy, and then you can establish a connection towards between Mallory and Norma and say, okay, hey, here is my key.
Yes, right. But the output of that is you end up with, again, the thing to focus on is what the people think at the end of the connection.
Yeah.
And there's only an interesting attack if
there's a mismatch between reality and
interesting mismatch in reality in this situation.
There is one more thing that I neglected to put on this side. This shows a sort of asymmetric relationship where one side is switched. If you walk through the process for switching both sides in, so you actually have two sessions to the attacker, and the attacker decides to switch its keys on one side for one and the other side for the other, you actually end up with an end-to-end connection between Norma and Patsy, and Mallory's not involved at all. Now, both people think they're talking to Mallory.
Right.
Yeah.
Now, you can do that anyway just by stitching the sessions together is the point.
Right.
So that's why it's not particularly interesting. There's some text in the draft about the implications for binding information from that substrate back into the signaling and the implications for that. But it's generally, it's not particularly interesting.
I guess what I would suggest is that if you think there's an interesting attack that doesn't require two concurrent connections, that you sketch it out and then we can discuss it.
Yeah.
We spent probably, 20 hours on this over the past.
No, way more than that. This has been like 18 months in the
right. So basically, I guess my point is, it's very hard to reason about on the fly. So I'd suggest you draw it and then we can discuss it once you drawn it.
Yeah. I think I will. Yeah, I'm happy to discuss it offline, that part. So,
Colin. So I'm talking about this a lot, and the most interesting attack I could come up to is a conferencing server. Can you go back just one slide? The conferencing service. Let's say it's WebEx is the Patsy here, and the attacker is Mallory, and the calls are actually generated out the other direction to Norma. And it's not like it does happen sometimes that you have a conference system dial out to you and you get two different calls and you drop one of them drops and you take the other one. It's just like, screwed up WebEx, right? Like it's not that surprising. But the thing is what made me feel that it was boring was in the end, after that's all happened, you don't think you're talking to WebEx. You think you're talking to Mallory. And so, in so much as you believe this secure caller ID has any never mind this attack, right? Mallory could have just phoned you and linked the media through. If you're willing to have the conversation with the wrong person, you get what you deserve.
Yeah.
So I couldn't generate an interesting attack out of it.
Yeah.
Jonathan Lennox, my question is, why is this here and not MMusic? Because it seems to me this is a 4572 problem with fingerprints, not with DTLS SRTP. And fortunately, Cullen has just caused
the solutions that we've come up. So DTLS SRTP is fundamentally the problem.
No, it wouldn't happen with.
It's 4572.
Yeah, it would happen.
4572.
It could happen with TLS also, I think.
Yeah. So
the solutions that we're proposing potentially belong here, don't they? Yeah. Okay.
Yeah, and fortunately, Cullen has just insisted that we do that 4572 business.
God, no.
So, so I guess just in case, it might help to be a little. Martin alluded to this, but the underlying source of this problem. So the same paper he refers to, the Sigma paper, it demonstrates that TLS style handshakes are resistant to unknown key shares, and the reason that they're resistant to unknown key shares is because the credentials which are carried in the handshake because there's no out-of-band signaling, also include the identities that are being attested to, and the TLS handshake, the MAC at the end of the connection basically attests the identities. And the reason this doesn't work here is because there's no identity concept. All there is basically fingerprint.
There is a session
just
somewhere
tied
in
to the signaling, right?
Yeah.
And so that's what creates this problem, and it's absolutely a problem with 4572. It's just that like the major consumer of 4572 is DTLS SRTP. So no, we should, and the fixes that are in our document are generic and would work with both TLS and DTLS.
Yep.
So
there was one more thing.
Yeah. So I mean, to wrap this up, so we can. It sounds like the actual place to do anything, this mitigation in the context of detailed SSRTP, at least with SDP signaling, is actually in music. The question if we need this generic, because all detailed SSRTP usages will most likely have similar behavior because we have
I did not get to the mitigation things. The basic property of the mitigation is to include properties from the signaling session in the TLS handshake. And there's different fixes for, there's another fix for WebRTC identity, which is also kind of different. So you identify the details of.
Yeah.
Roughly, yes. Basically, what you do is you effectively include in the basically you include the randomness you intend to put in the client server hello in the in the SDP.
So what is your next step with this,
Martin?
Well, that's kind of what we're looking for.
Okay.
Thank you.
So this does not reach my like alarm bells really scary. It does reach my, oh my God, every time there's a hole like this, someone smarter than us figures out how to exploit it. So I would suggest that we write a draft, which is an extension to the fingerprint thing, not in the current open fingerprint document, that adds on the end of the fingerprint line a, comma, extra randomness equals foo sort of parameter or something like that. That would clearly solve the problem. Well, whatever. We stuff it in a backwards compatible way. We add a equals fingerprint randomness. Right. Yeah. No, exactly. That makes sense. So that's probably better. But we come up with an extension which, if you do not know or do not know that extension, you're still this attack happens and it doesn't change any of our syntax at the SDP level. And we have some extra syntax that allows you to mitigate this attack, and we recommend people start using it.
Let me just respond to that. So that is a perfectly workable solution. We discussed adding something to the SDP. The current draft does not require any changes to SDP. It relies on stuff that's already in the SDP that's required to be unique. That's the version that I went with. I know that you might have been a little bit unhappy about that, but that's what we went with.
Yeah.
I gotta apologize. I haven't read the latest draft, so I didn't realize that. I'm happy to consider any. Look, let me rephrase very broadly. I propose that we pursue some approach to solving this problem, but it doesn't hit my emergency level.
Yeah.
And John Max, I suspect for most implementers, adding things to SDP is going to be much easier than adding things to the TLS stack. What? You don't need to change the TLS stack? Okay, I thought you were saying something like put the...
Can you talk to the mic?
Okay, so yeah, Ecker says that you need to change the TLS stack and the SDP, so... Okay, so anyway, I think my point is this should be done in music because it's a 4972 issue, which applies not just to DTLS SRTP.
Yeah.
Yeah. So Martin Thompson, you can't get away with just modifying the SDP, as far as I know. I don't. This is complicated, and I don't have it all in my head. But the model that we've adopted is to take something from the SDP that is unique to the SDP. That could be something we add to the A equal fingerprint line or something else, and you put that in the TLS handshake, and you check that it's correct.
Yeah.
And that sort of serves as a proxy for identity in the Sigma sense. And that sort of partially addresses the issue. Well, solves the issue. We actually have, thanks to Tyler doing some work on this, we actually have an analysis that sort of suggests that the attack exists and the attack is addressed by the change.
So yeah, one comment about this. I think the general security consideration and the fact that the attack exists is actually something that should be updated towards the DTLS SRTP spec. So, but we might have, but the actual mitigation we can do today is probably around STPs. So, and combine. So it's.
So your recommendation is to take this to MMusic.
I think so, yes. But we with potential to actually at least have some updates towards the detailed SSRTP spec, just because to get the link from the attack to the document. So we have to think about that, how we do that specifically. But
yeah, I'd say we can talk about updates and have that discussion again.
But my point is we need to have something that alerts the detailed SSRTP implementer in general that this attack exists, and it's something you need to consider in your signaling system when you try to apply it to new.
Right. So yeah. So my reason not to go. Yeah. That's a bug. Yeah. The reason I didn't go to MMusic was that there are no SDP changes in this document. I sort of thought that was not the right thing to do, but obviously we can go wherever everyone thinks is appropriate. That's easy.
Yeah.
Okay. Oh, you want to dispatch it? All right. Consider that a request. I'll put in a formal request on the dispatch list.
Can we please move on? We need to figure out how exactly this is done, but we don't need to do it here. I think.
The one question I have is: do we have any solution for the session splicing issue, or is that harder?
The solution to session splicing is to use some form of identity system on top. I think would be the sort of simplest way. So if you're using WebRTC identity, you're not vulnerable to the splicing thing. And if you're using
really?
Some other
Let's talk about it offline.
Yeah.
Yeah.
It's in the draft.
Okay. So moving on to the next topic for the last 4 minutes or so, at least we will be able to determine what people think about this, even if you're not going to the details of the charter. So this is to discuss merging AVT core and AVTEXT into one working group again. So So I mean, the history here was really we split AVT into AVT core, AVTEXT, payload, and extra block. That was due to mostly too much work on too few shares, and also enabled focused participations on the different topics. If you, for example, only interested in payloads, you didn't have to listen through all the head RTP extensions. So, but the current situation really is that we have a quite light workload in AVT core and AVTEXT. It's mostly the same participants as we show here. I've seen very few people coming and going during the switchover in this session. So, next slide. So the proposals really from us chairs and talking to the ADs is that we remerge AVT core and AVTEXT. Payload and XR block will continue as individual working groups. So I want to have a discussion around this. Is there any opinions around this, etc.?
This is Ben Campbell. One of the reasons for this is, at least it's been my observation, that when working groups drop below a certain level of activity, people start paying less attention, and then when activity happens, they don't catch it and they don't notice it in time. So, weeks later you get I cared about that, but I wasn't reading that list. So if nothing else, I hope maybe this can make sure we stay a little bit above that threshold. We've seen that happen, in the SIP core and things like that. So.
Hi, Colin Perkins, merge them. In a lot of ways, I would actually suggest you might consider merging payload and XR block as well. In particular, XR block has very little work, and there was talk of that group closing down. But I think we need a home if there are new XR blocks. So rather than keep a working group alive just in the off chance that something will appear, I would just say put XR blocks into this merged group. Whether payload is part of it or not, my impression is there isn't enough payload work to justify a separate group, but I don't care much either way.
Hi, Alvestran. Just because you've heard me say this before, I regard calling review panels working groups is a really bad idea, and we shouldn't do it. We should shut down both.
Okay.
But in the interest of consensus, I'll say that one review panel masquerading as a working group is better than two review panels masquerading as a working group. Merge them.
Colin, I'm fine with this. It makes sense to me to merge those two. But I think that part of this is that since we've moved to the AD sort of being less specific to a working group and balancing more across multiple working groups, it doesn't make that much difference from an AD point of view, which was one of the things originally driving the split more. And what you're, if all you're really discussing here is which email list I should use, I don't even care if you have, 5 working groups all with the same email list that all use the same email list, right? I mean, that's all you're talking about is like, whatever. And I don't find that, the odds of me reading 2 email lists are, I can choose to filter them both into one box or not. I mean, it's like we're into the gibberish zone at this point.
Jahed, channeling Bernard from the Jabber. Support calling suggestion to add the merger. Jahed, as Jahed.
Yeah.
I also think this should be merged. I mean, the presentation I have now, not looking at the history, it's like the working group chairs load. And if things are I have been observing last 2 IETFs, AVT core and AVTX, and it feels like it could be manageable by one working group.
Yeah.
So I think it should be merged. And I kind of also like Colin's idea of merging XR block and payload. Yeah, thank you.
So as far as XLR block and payload are concerned, those are possibilities for the near future. I know, I don't think Alyssa's here, but she had discussed with the XLR block chairs that they would prefer to stay open for a little bit longer. And I think payload has some different dynamics to it. But just because we're merging just these 2 now doesn't mean we can't merge more in later.
Mo was an Addy +1 on the merging of at least AVT core and AVTX, and also +1 for at least merging XR block as well. And if you don't immediately merge them, maybe at least do like we're doing here, co-locate all of the sessions together so that we can see how it works as a physical merger before you actually do the alias mergers. Logically belongs to AVTX too.
Yeah, John Lennox. Yeah, I mean, I think, I agree that payload's dynamic is somewhat different, and back in the days of AVT, the payload formats were always the really dull parts that nobody else cared about. So I would be inclined to keep that out. But XR block, I mean, it doesn't matter that much, but I would think, mostly so to make reviewing Colin's draft easier.
Yeah. Okay. Thank you for your input. I think we're gonna continue discussing this. I got quite clear where we're going with this, etc. But the actual details, etc., will have to be figured out. There will be a shorter proposal, I think, circulated. So.
You want to go on the charter? Or?
No, we over time now, so we will.
So we'll post it to the list.
Yeah, but we'll post it to the list. So
we have a proposed charter that will be posted to the list for the merged.
So thank you, everyone. See you whenever we see it next time, and under which name we will see. So.